Thank you for joining XROM, which is India's first AR/VR focused podcast. And today, I'm delighted and honored to have with me Mr. Mukundan Govindraj, who's currently the principal solution architect at NVIDIA Omniverse. He was the extended reality practice lead at BCG Consulting. He was a writer curator at his own firm, Immersive Leaks. He has over 14 years of experience in immersive technologies, industrial metaverse, digital twins, computer vision algorithms, and real time 3D solutions. He has built and led 500 plus digital twin and metaverse experiences. So, Mukundan, really a pleasure to have you on the show. Why don't we start with a small, brief introduction and background?
Thanks. I'm super excited to be here, Eddie. It's always a pleasure talking to you. Being a fellow metaverse enthusiast, it's always nice to share thoughts and ideas with you. So, I've also been helping companies and industries also pick up metaverse as a large spread practice by itself. So that's also something which I've been working as part of BCG as well as NVIDIA, where I help them set up the COEs and the whole stack that is required for them to be successful when they go to market to their customers. And beyond this, I also work closely with the universities in India as well as in UK, where I help orchestrate their syllabus to cater to the latest demands in AI and metaverse, both in engineering and science.
Just to set context, and before we get into BCG and your current position, at NVIDIA, I would like you to kind of give your opinion on what you think the metaverse is and how it's going to impact society.
I would say each one has our own definition of metaverse, and each one of it is absolutely 100% accurate, right? So, because it's a continuously fast changing term, what was being described as metaverse yesterday may not be the metaverse of today, and may not definitely will be something different for tomorrow, right? So, again, if I'm going to talk about metaverse, I'm going to split that into industrial and the consumer metaverse. So, the consumer metaverse is purely about user experience, how to increase the social engagement factors, and more likely now we speak about uh, purchases, crypto exchanges, and the M platforms and things like that. Industrial metaverse, on the other side, is purely about photorealistic realizations and also physically accurate simulations, because these form the basis of the industrial metaverse. Because when we talk industrial metaverse, we are talking about building massive 3D worlds, which lays the foundation of working digital twins. And apparently, for us to achieve that level of accuracy, we also need the basics of photorealism and physical accuracy. And that's where it all gets started. Yeah.
So you've been, in the bio, it says you have done 500 plus digital twins and metaverse based experiences. And this is largely for BCG. So first, would you like to kind of explain what digital twins is and maybe share some of the works that you built over there for digital twins and metaverse?
Yeah. So to talk about digital twins as such, most of the journeys, the way digital twins are defined is by the books, right? It's a digital replica of a physical entity, right? Having a one-to-one replica of what the real space would look like in a digital world pretty much confines the term of digital twin. But what people can do with it is above and beyond that. Most players they start with a digital twin apparently for them to pre-visualize the setup before they go and commission a factory or before they deploy it at a large scale. And most of the digital twins stop just with that. When we talk about a true digital twin, what happens is apparently you use the world to create a one-to-one virtual space, and on top of it, you can run a n number of simulations. A quick example for a factory is running predictive maintenance. You predict before a machine when a machine would fail. Apparently, you train your robots in a virtual setup using AI, and you can use the same AI to understand and recognize patterns of how things work, and you can bring together a massive digitally synthetically generated data, which again goes into feeding into the AI and apparently making the AI more super intelligent. So when we take this part, And that's where we are talking about a true digital twin, which is full in one connected in real time. So which means whatever is happening in the real time in the factory floor gets a data update onto your virtual digital twin. Apparently, it is also automated, powered by AI, and it can help you in taking decisions on behalf of you in the functioning of your day-to-day functioning of your factory. So the scale is massive, and this cannot be definitely built over a period of a month or two. It takes its time, and it has a massive process by itself.
Right. Can you share some example as in some works you have built over here in India for a specific industry, for a specific company, and how they benefited?
So stage-wise, if I'm going to approach the whole development, the first and foremost thing is world building exercise, where you bring together all the various different ecosystem of tools under one platform. That's a place where Omniverse provides an amazing framework. It does not replace any tools, but it apparently brings together the wilder gamut of tools, different ecosystems all together, so that you can start having a real-time collaboration and having a seamless experience. And you can have people from different parts of the world coming together and collaborating in real time. So that's the first stage of having a digital twin. The second stage is building your own customization pipeline and running physics related simulations. This could be CFDs. The biggest requirements in an industrial simulation, we are talking about an accuracy which cannot be achieved using the game engines. So there are specific industry related tools like the ANSYS and NVIDIA as a modulus, using which you need to run those physics solvers, domain solvers, so that you get a very really accurate simulation. It could be of gaseous matter or water related matter. Once the simulation is done, then it is rendered using Omniverse, which helps you in RTX based rendering. And that's the second stage, right? This includes CFD based, non CFD based, voxel based simulations that is required to make the world much more interactive. Then comes the third stage where we need to connect the data. So we have a massive IoT layer, physical IoT layer, and this data has to talk to our virtual twin. And how do you establish the framework? You may get started with something as simple as a REST API, plus later you might be using your own IoT platform layer, which apparently has to come together so that they have a live real-time sync between what's happening in the real world and the virtual world. And then comes the fourth stage where you use the AI to automate most of the process. It helps in decision making. If you look at this massive process, this is again the process that we would follow for a true digital twin. This could be easily anywhere between 6 months to as long as 3 years. But once done, you will start seeing the benefits and ROI from stage one itself, where you apparently bring together all the ecosystem under one umbrella. You'll start seeing the benefits, and over a period of time, there will be continuous benefits that you will reap.
Largely, through the course of the conversation, whatever you mentioned is examples for big industries. How do you think XR, metaverse, AI, IoTs, 5G is going to help small and medium enterprises? Possibly share some applications also.
Great questions. Honestly, the way the big companies started adopting, right? This adoption is happening right now. But in the last 10 years, while we were working, it was purely the startups who were experimenting and kind of fueling the test bed, apparently, in the various fields which you've mentioned, from IoTs to XR. Apparently, you will see much more startups who is currently supporting and building for the larger enterprises. That was the scenario at least until 10 years back. But now the shift has happened. Now even the bigger companies, they have a larger team within their own payroll where they are building their own ecosystem. And if you're looking at these XR applications kind of reaping benefits for smaller companies, the first and foremost area where there is a massive acceptance is purely in the L&D area. Learning and development area has proven to be super successful and has proven to be a good ROI when it comes to XR as a technology. IoT layers, again, if you see now, everything is connected from as simple as your washing machine. 5G is started making the next big wave. And once 5G comes into picture, we are talking about cloud computing, which would happen all in the back end, and we can have all lean, low-end mobile devices where you can stream 50 billion polygons. And all of this is going to completely disrupt the need even for a smaller companies to go and invest, because everything becomes, see, when we talk about a digital twin at a scale where we're talking about massive infrastructure requirements, now the game is already shifting towards a lean end device, and it can be a Chromebook where you can run a simulation which is super realistic and real time, and the server which is going to be running in the backend, and you pay it as a per as you go basis. It is like your AWS, which has completely demarketized the way the initial data centers were, right? So initially setting up a data centers was a gameplay for larger companies, but now if you are running a startup, when I was part of startups, we go and quickly get an AWS account, and we get access to super powerful servers, and then you build your solutions and then you start deploying. That's exactly has come down to metaverse right now. You can have all those super powerful compute running in the backend, and you can have your mobile device as your end device, or even a Chromebook where you can run interactive realistic 3D simulations, which are not game like, but I'm talking about realistic simulations. And that is completely going to make this technology affordable. At the same time, it's avoiding the need for a smaller or a medium-sized startup to go and worry about keeping it updated, hardware updates, software updates. You don't have to worry about any of this. You build a solution on top of it. You can start consuming it if it is for your own purpose, or you can start building products on top of it and make it available for your customers. So either way, the whole tech stack has become more affordable. And another great example also, which I would like to cite here, is what Meta did with their VR headsets. They were able to provide a super powerful, one of the best piece of hardware, which is their Oculus Rift, a Quest, I would say, at a meager $300 in your hand. And it's if you look at the cost, it's just one fourth of what an iPhone would cost in India, right? But the value that it provides is huge. And in fact, the company took a toll. What I read somewhere was like it was losing almost $400 on every headset that they were selling. The reason is they want to push the product, this great product, and socialize the technology amongst a larger audience, so that it's not only a meant for a premium audience. It could be accessed by startups or middle scale, or even people who are trying to experiment it. They get this amazing technology in their hand.
Right. Yeah. I think what I take from here is the democratization of technology. I think, access uh, of the tools, you know, uh, at anybody in anyone's hand, the ones who got the desire and intent, I mean, they could be, building a small startup and can be changing the world. And you mentioned also Meta and how they've been, I think, the single company which is completely redefining and put into public attention with the metaverse virtual reality conversation. Though they have their negative side, but the positive sides are loaded. I think they're the ones who are completely driving the conversation and taking the huge hit of uh, putting a customer ready virtual reality headset for a price point which is very, very cool, and they're taking a huge hit now. You spoke about this democratization of technology, and I see a lot of really interesting startups doing some really, really cool thing. Amongst them is Luma AI doing some awesome stuff with nerves. Do you think so you mentioned about the game is shifting, so maybe address that and possibly elaborate that on how this pace of innovation between big tech and startups, the gap is closing down. What are your thoughts on that?
Oh, very interesting and also a well thought through question, I would say. So during the course, since I've been working on this tech, it somehow created a curiosity in my head that I should be continuously learning. If I don't go and read something today about this tech, I feel that I'm getting older. So, and honestly, that's how we should be all fellow immersive tech folks have to be, because Every day there is some innovation happening. So what it all started, and the whole pattern, if you see, is like it started with people behind creating all those 3D assets. That's how the whole world began. And once during the course of couple of years, this whole tools got more matured, and people were able to build these 3D assets in a much better way. But now we are talking about commands, generative 3D, where you can key in few keywords or you can talk to a machine and it'll create those fancy 3D assets for you. And that's how the technology is getting comfortable. And there is also a kind of a fear factor which would come into people's mind when they see this tech. Hey, am I going to lose my job? Right. So these kind of misconceptions definitely slow us down. But apparently, the acceptance is going to make our job much easier because these technologies, the world, the need for 3D worlds, right? After Metaverse created this massive wave, the current pipeline that we are following for this the 3D pipeline, it's a pure waterfall model. If you, since you know this, and most of the folks who might be hearing this also would understand with this. So it starts with modeling, then you do texturing, then you do the rigging, animation, and then you push the file either to a game engine pipeline or to a render pipeline. And this is a pure blood waterfall model. And this whole process is being followed across the world in all possible industries when it talks about building 3D or VFX, right? Now we are talking about completely converting this waterfall model into an agile model where all people, all different designers can work in parallel. And that is already been possible right now with simple adoption of USD file as a file format. And again, Omniverse is a tool which helps you do this. Apparently, the main source of this is acceptance of USD as a file format. Because in this current world, we are dealing with at least 10 different file formats. The acceptance or a acceptance of the various pain points and the urge for you to go and solve it is going to apparently change the whole the way you would see things. Likewise, while you're doing this, there is generative 3D, which has already come into picture, which is solving a lot of heavy lifting, which you would otherwise end up doing it manually. So that's again an acceptance factor. And now when we are talking about Nerve as a tech, again, the technology itself is in a very nascent stage. There's only so much you could do with it, but you need to start accepting and then find or insert that into your pipeline in a way where you actually can make benefit out of it. If you would want to use Nerve for going and doing a full-fledged interactive 3D pipeline, it's not going to help you at this point, at least, right? But you can definitely use it for, let's say, you want to build the world where most of them are not going to move a lot, then in that case, Nerve can be a great addition. And on top of it, there are APIs which are being built. In fact, there is this um, a Nerve plugin which was completely open sourced, which is available right now. Even NVIDIA has an instant Nerve, which can be blended into your blended pipeline with a API. And then on top of it, you can build 3D assets. So that is something where the acceptance is more and people see much more use case and they're going towards it. And if you look at this whole spectrum, if you see most of this heavy lifting cannot be done by an established company. And most of these heavy lifting right now, experimentations are being done by startups which are pretty well funded and they are focused. And the way it's currently being worked is, and this is a pattern, right, which you would have also seen. AR, VR 10 years back was purely done by startups. Now, once it's kind of matured enough, larger companies have started building their own teams and started providing it as a service offering. So likewise, the new experimentations happening around generative 3D or Nerve, all these things are currently being experimented by startups. Of course, they are funded massively by VCs and larger companies. And once they get to a matured state, it will start being engulfed into the actual pipeline itself. And this is only getting better and better because if you see what it would have taken 6 years time for a product to get matured, now it's apparently happening in probably one tenth of its time because of the powerful hardware which is available at dispense, and secondly also the way the maturity curve is predicted. It's pure blood acceptance rate because now it's all driven by demand based. because there's already a demand which is created for 3D. So anything, any new technologies which is going to be built around this tech, the acceptance rate is already created, the demand is already created. So their time for the product to get matured and accepted is kind of shortened here.
Right, right. Yeah, so I would want to, I mean, you to elaborate further on generative AI and large language models and things like that. But before I get into that, I mean, I want you to talk about NVIDIA Omniverse, because today I
Mhm.
think, there are quite a few 3D engines doing really, really cool. I mean, among your peers, whether it's Unity, whether it's Unreal, Blender, and so many others. What is NVIDIA Omniverse, and
Mhm.
how is it different from the other 3D engine platforms?
NVIDIA Omniverse by itself, it's a scalable end-to-end platform for building and operating metaverse, industrial metaverse applications, which includes 3D world building and real-time digital twins. So you can look at Omniverse as an engine to build digital twins. So apparently it is also not a game engine, so that's where we do not compare ourselves with Unities or Unreal, but we are very friendly. We work directly with them, and we are kind of building that ecosystem, right? So right now, if you see in this world, there are different file formats available, which talks about a waterfall model and multiple exports involved in the whole process. So we are saying that we are not here to replace any of your tools like Max, Maya, Unity, or Unreal, but we bring the whole tool ecosystem together, and we are making your current pipeline super efficient and enable real-time collaboration. So that's the place where Omniverse is going to help you out of the box. And once you have this, on top of it, what it will also provide you is realistic physics simulations, voxel-based physics simulations, and on top of it, you can run CFD simulations, which is more industry specific. And apparently, we have reference applications where you can, like Isaac Sim, where you can train your machines, train the different types of robots which you deploy in your factory floor, be it a manipulation robot or a navigation robot. You can 100% train all these robots in Omniverse in a digital environment. And then once you have trained it, you take this data and deploy it to the real world robots. Likewise, we have applications like Machinima, which provides you a lot of AI based tools which will help you do a lot of animation purely based on AI without having a need for you to go and manually do animations. So if you look at Omniverse, it's a AI driven digital twin platform. It's an engine to build digital twins, and apparently it's continuously evolving. So when I say it's continuously evolving, we have something which you can get started with today, but we are continuously adding more and more features. As to when we work with our customers, we realize that, hey, there is a need for us to build a pipeline between the answers, which is what some of our industries are using. How about we merge and blend the data from answers inside Omniverse? So we build that connector so that we still let the end users be comfortable with the tool that they continue to use, but they can push the data into Omniverse for getting the realistic rendering. And that's how the whole platform works by itself. And the big misconception is it gets easily compared with Unreal or Unity as a game engine. But Pureblood, when we started apparently building the first digital twin, because NVIDIA as a company in the last couple of decades have been working on professional visualization. We practically invented GPUs. Uh, and then once the AI got matured, we had a need to build a digital twin for customers. And we, in fact, started the journey with an existing game engine. But during the course, we apparently realized that we need something else. And for us to go in full throttle, we had to build something from scratch. And that is how Omniverse came into picture. So if you already have a pipeline with a different tools ecosystem, including DCC tools, game engines, simulation engines, we already might have a bidirectional connector for it available, which means you can start communicating and work together. If not, we also help you in building those connectors so that you can start establishing the connection in your current ecosystem. And this is purely only from the design phase. But on top of it, you can run simulation, which also helps you in running and operating a real-time digital twin. Plus, we also have the power of GeForce now and cloud virtual systems, which all come together to help you provide a massive, powerful backend and a lean laptop or even an iPad through which you can access these realistic digital twins. So this makes and the need for you to invest in a very expensive hardware to access these digital twins if at an on-prem basis.
Lovely. Mukundan, I would like you to elaborate a little bit further on NVIDIA Omniverse. You mentioned about
Mhm.
the engine being able to accurately simulate real-time physics, and that's been the problem, from the water simulations to your trees, and so on and so forth. uh,
Mhm.
a When do you think we will be able to accurately mimic the physics, the real world physics, every little thing? B, what are the applications, I mean, which is really driving the conversations, where the biggest industries are using it's autonomous vehicles, robotics? So maybe if you could speak to that.
Mhm. So to get to 100% realistic physics, it is doable right now. So the tool is capable of helping you in simulating realistic physics starting today. And the major applications, if you see, is purely uh, in training AI. So there is this concept of synthetic data generation which emerged few years back. And maybe before I answer that question, I can give you a context of what is synthetic data generation, why it even came into picture. If you look in the current world, we have probably several billion IoT sensors being deployed in all possible form factors. If it's in a car or in a factory, there are possibly several billion sensors which is continuously collecting data. But what's happening is, yes, we have the data, but is it meaningful? Absolutely not. So what has to happen is there's a probably like several thousands of data engineers who work behind it and start making sense out of this data. And it's practically the process is called annotation. So you try to make sense of this data so that the meaningless data gets some meaning. And then you take this data and feed it to your AI programs so that your AI becomes smarter. If you look at this whole process, it's a lot of industries, a lot of companies have stopped doing this meaning mapping of the data purely because it's resource intensive and cost intensive. It's a time intensive experience, right? So they have pretty much reduced their uh, team to go and make sense out of this data. So that is where the synthetic data came into picture. So synthetic data generation as a concept, it helps you in virtually generating all these data sets. Since you're generating, your system is generating this data, even the hypothetical scenarios. Let's say, for example, you want to create data, let's say in Bangalore, where this is purely for autonomous vehicle. So the various unimaginable scenarios are like, let's say you are in Martha or in one of Sarjapur main roads, and a massive boulder or a bus falls down from the flyover and the car is moving underneath. All these kind of hypothetical scenarios. Suddenly, what if there is a snowfall? What if there is a big tree which falls in the middle of the road? All these kind of what if scenarios can be easily recreated and generated in a virtual setup, and this data is already annotated. Once it is annotated, the meaning is already defined, and this data is also considered as a golden data. And this data, when you supply it to train your AI programs, it gets super efficient. And on day one, when you deploy it, it's already starting from 60 or 70 instead of starting from zero. And this is one of the largest application of using realistic simulations, physics simulations. Synthetic data generation, it cuts across. It's not only for automotive industry. It is heavily used in the industrial simulations as well. in drive-related operations, in factories, in healthcare, in creating new drugs. Synthetic data is being used, where you can create million scenarios, and all of this can be generated in less than an hour by running 1,000 different instances, and you get this data generated, and then you go and train your AI on top of it. This is one of the largest applications when it comes to physics-related simulation. The second one is also related to product design. Say, for example, the aerodynamics of vehicle is one thing which I can talk about. The wear and tear, if you would want to simulate a wear and tear of a product over a period of time, this can be done using realistic physics and synthetic data coming together. And the whole idea of generating is purely demand driven. One, you may not be able to generate such a data in a real world. Two, you may have the data available, but you have a hard time annotating and making sense of it. In these two scenarios, you switch gears to synthetic data. Apparently, this is kind of providing a largest ROI, I would say, when it comes to physics simulations. And also, there are some few other unique examples like forest fire simulations, where we have partnered with WEF, apparently also with Lockheed Martin, where we help uh, create the pattern and simulate the actual forest fire of how it would uh, expand and in what direction, how the wind speeds and the pressure in that region will have an impact in a forest fire scenarios. All these data was fed and it was able to realistically replicate the actual forest fire, the rate of spread, which also gets affected, and also the heat which it generates kind of also fuels the growth of increasing in the radius. All of this was 100% realistically simulated. That way, if there is a forest fire, we know exactly the rescue team knows exactly how to take the rescue measures and also how to reduce the spread. So these are some realistic scenarios where physics simulations apparently um, is solving real world problems.
If there is enterprise over here who would want to leverage the services and solutions that you offer, where and how they can get in touch with you, and what's the support system here for the Indian enterprise that you have?
Yeah. So the first thing is like we have a go-to-market team who is available. Apparently, we can also send the web link how through which they can reach out. And even before that, my suggestion is to try out the Omniverse because most of the use cases is already kind of proven. And if you feel that Omniverse is going to solve your problem, my suggestion is first download the software, start using it, get a feel of it, and then once you see that there is a dire need to, adopt it, then we will be able to put you in touch with our go-to-market team. And we have account managers who work by the industries. They are categorized by the industries who will help and sit with you, work with you in identifying what's your pain point and help you in building this whole gamut of architecturing the whole solutions for you. And then you can start accepting it and start deploying it at a larger scale. And this is apparently how we approach. But feel free to download the software yourself if you want to play with it. And we will be able to share it on the description if you would want.
Super. Mukundan, really appreciate you taking time and being part of the conversation. Uh, Exciting times. I think in the next few years, every industry is going to get completely upended. I would like you to end this conversation on generative AI because that's the hype cycle. Large language models going crazy with ChatGPT. You have generative AI going crazy with image to text, image to video, image to 3D. How do you think this is going to pan out? And which other industries which is going to get affected? Possibly paint a picture on how the world is going to change with
Mhm.
generative AI, large language models.
Yep. And that this is one of the most fascinating topic which I enjoy reading about, experimenting about on a day-to-day basis. So the idea is like, again, I'm going to take an example from the history. So it all starts with, people experimenting and COEs. When a new technology comes into picture, you experiment it. And once it is matured enough, then you put a large set of people around it to globally adopt the technology. And then once you feel that the adoption is kind of great, then you try to automate the technology. And the automation phase is where most of the metaverse related solutions are, right? So the tools got matured. Now it has come to the automation side of things where we are talking about adding AI into it. So that's what is generative AI is all about. So what took a designer to go and do on a canvas, later he started doing with tools like Photoshop. Now a non-designer can talk to a tool and help him in designing a great, beautiful piece of art. Yes, there is resistance from multiple sides because that's very common through the any process of when a new technology comes into picture, right? There is going to be some resistance, but if you look at the larger benefit, it's going to cut down a lot of time and money otherwise, and also valuable human hours, which apparently would end up doing a lot of repetitive tasks. Now that all those great data has already been fed into a machine is doing all of this at a blink of a second, which is kind of offloading those repetitive tasks which otherwise would be done by a designer. Now designer's mind is free to go and do something new and something more which is more human mind driven. So the same concept is being applied to 3D as well. Yes, 3D is going to take a few more years. Apparently, yes, there are some great solution. Even NVIDIA has a Magic 3D through which you can create those 3D assets. But the gap is how do you get meaningful 3D assets which are game ready, which are pre-rigged and pre-animated and stuff like that. Yes, all these research and products, there are tools which is available for you to just key in a text and animate a character. Yes, all these are available in bits and pieces, but it will take at least another couple of years where all these technologies comes together, and then you have a more refined solution as you have right now for a generative art. Generative art is pretty much matured now. There are multiple players out in the industry who is providing a fancy UI to help you create the art. The 3D is apparently going to take a couple of more years to mature, and once it gets, it's again because it's going to offload a lot of repetitive tasks that a 3D modeler or an animator would do. Right now, if you see Machinima as a tool, this is part of Omniverse, you can actually explore where you can do all the fancy, realistic human walk cycles or run cycles or any human related, biped related animation just by feeding a video as an input, and it'll automatically detect the pose and apply that pose to the rig. These are some a boon, I would say. These are some amazing piece of tech which will kind of uh, make the process super easy so that you don't have to wait for a 10-member team to build your metaverse application. All you need is a decent knowledge of the tools, how to maneuver through the tools. With maybe very few member, 1 or 2 member person, you can start building the metaverse applications. The reason why I'm saying this is not going to reduce the number of jobs is because the demand is exponentially increasing. Every person understands the benefit of 3D, and the demand for 3D has already skyrocketed. If you look at the current VFX industry, they're all running in full capacity in India because of the need for the and Netflix and Amazons and whatnot. It's running in full cap. And we need more people, or we need more interesting tools which will offload most of the repetitive tasks so that people can spend more time on places where they need a human intervention. So this is only going to get better and better on a daily basis, and we should have a open minded approach towards these technologies because some might fail, and we should also accept that when it is failing we should not cling on to the tech because it's going to look fancy, but at end of the day, is it really solving, is it able to meet the ROI? These are some critical questions as a developer, as an entrepreneur, you'll have to keep in mind. If you feel it's not going to provide you the ROI, then it's no point in you investing in such a piece of technology. Rather, there are amazing alternatives which you can still consider as part of your journey and later adopt to something more substantial. So it's an amazing space. Generative, yes, I've always been a fan, and I would like to see the generative 3D come into a practice pretty soon.
Lovely. Mukund, I really appreciate you taking time being part of the podcast. I think we're living in an exciting point of time. and tech is accelerating at the speed of light. Training these AI models are becoming more and more cheaper, and there are companies such as Stable Diffusion, which is democratizing and creating accessibility. This what once was a tool only for big tech. Now it's accessible for everyone. And yes, there's the one side of the conversation. I completely understand that this will create more jobs rather than taking away of jobs, but the fact remains that that the world is going to be upended very, very fast at the speed of light. And I think every organization, every education institute needs to look into the future, peer into the future, and understand where these new tech ecosystem is going, and have possibly their students, the workers, looking into the future rather than the current workflow. Because I think every week, every month, the entire workflow itself is getting upended. So
Yep.
we need to keep in touch with the way the tech is accelerating, and also keep an eye on the far out future. The reason I say this is
The acceptance.
we love the opportunity of having these tools add more value to our life, like starting from whether it's the basics, the phones, the refrigerator, or the ACs. What is that point where the tools overtake us? And I don't really understand that line, because we are fast moving from narrow intelligence to possibly maybe artificial general intelligence, and with the more and more tools out there, which is constantly enabling us to automate things, and we not understanding AI completely, because in all fairness, it's pretty much a black box. The kind of, it takes those billions and billions of petabytes of data and infers. We still do not know how it kind of infers valuable insights from that use data. So yes, my thing through this podcast is to raise awareness on also not just being short-minded, but also looking into the future where having governments, enterprise, society, all come in together and create conversations on how to create a tomorrow which is better, where the man-machine convergence is beneficial for humanity. So thank you once again for taking time and being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye-bye. Thank you. Thank you, Mukundan. Really appreciate it.
Thank you, Eddie.